Today in this video, we're going to be discussing the entire concept of sliding windows in data structures and algorithms. So sliding window is basically a control system which helps us to solve very typical problems in DSA. It is a variation of two pointers wherein we use one pointer at the starting of a window and one at the ending of a window, and while traversing a particular given array, we can shrink and expand this window to accommodate all the desired outcomes and also derive the result that we want to obtain out of this particular scenario. So in a sliding window, there are two things that we can do as I just discussed. There is, if I have a window, I can either shrink it or I can expand it. And if a particular window breaks the rule, I shrink it. If I want to accommodate more entries, I expand it. So this is the basic principle, and everything depends on when the window becomes invalid. So we need to be sure of when this window becomes invalid, right? So there are two types of sliding windows that we are going to discuss in this video. The two types are, there is a fixed sliding window and there is also a variable sliding window, right? So for a fixed sliding window, what happens is that the size of that particular window is very constant. However, in a variable sliding window, the size changes based on the condition. Size always varies. Okay. So here in the fixed window, for example, if we are traversing an array, right? If we are traversing an array, we are given a particular size, for example, k. So we have to traverse the array in size and intervals of k only, right? So like this. And then we always evaluate things in the intervals of k. So this is how this fixed sliding window operates. However, in the case of a variable sliding window, we are given a big array, but we are not expected to have a fixed size through which we are traversing it, right? So here we can go from a certain starting point and then move on to a different ending point and then so on. So for a variable sliding window, it can always vary with the size. So when we expand a window, we can also shrink it, and then for example we start this at some particular size k, then we can also go k minus 1, k minus 2, k minus 3, and so on. So this is how the two types of sliding windows operate, right? So there are different types of examples for sliding windows. There are very standard leet code questions as well. You can see the maximum size subarray of size k. Then there is also leet code question number 3. Leet code question number 3, which says the largest substring without repeating characters, right? And these are all examples of typical sliding window questions. So now I'm going to discuss the different templates for solving a sliding window question, right? So there are three types of template that are going to be primarily discussed. So there is obviously the fixed sliding window pattern, and then there is variable sliding window pattern, and we are also going to do a bit of a different type of an advanced pattern in sliding windows, which is the count subarrays template. Okay, so these are all the different types of sliding windows that we're going to discuss. So in the first fixed window pattern, we first of all we take 2 pointers, as in most of the 2 pointers question and in sliding windows questions, we take 2 pointers left and right and we start traversing the given array. So L is equal to 0, we initiate this and then we run a for loop for int r is equal to 0, r is less than n, which is the size of the array, and then r plus plus. So this is the left and the right pointers. Now we go ahead and add this nums of r. Now we check the condition if r minus l plus 1 is greater than k, which is the particular size of the window where k is equal to size of the fixed window, fixed size, right? So if r minus l plus 1 is greater than k, then we remove nums of l and l gets incremented. And there's one more condition that we add here, which is if r minus l plus 1 is equal to k, then we update our answer. So these functions of adding numbers and removing numbers can also have different conditions, but this is just a basic template that we can follow in order to solve any problem of a fixed window template pattern, right? So then there is the second one, which is a variable sliding window. So since there is no fixed size, there is no parameter also with us. So we don't need to take and assume any value of k or anything. And we can just dive straight right in to this entire template. So again, here we take 2 pointers, the L pointer, which is also initiated at 0, and for int r is equal to 0, r is less than n, r plus plus, we add or include the nums r, just like in the fixed window pattern. This is very similar, but now instead of just adding a very simple if condition, we go ahead and we add a while loop. Now this is one of the most widely used patterns in DSA. I mean, for every question that you're going to encounter in DSA, there's going to be a variable sliding window if the given question is of a sliding window pattern, right? So variable sliding windows are very, very common, and it has a very simple template as well. So this is a for loop, and then there's a slight while loop, and then we go remove nums l and l plus plus. So instead of adding an if condition, we just resort to a while condition, and then we also add a semicolon because we need to end the line, and we close the brackets. That's literally what it is. I mean, you just need to identify the condition where the window becomes invalid, and then you go ahead and remove the nums l. Now for the third pattern, which is quite a bit advanced than the others, and it is not as widely used, is the count subarrays template. But it is very handy to use in case you're ever asked that kind of a question. So int l is equal to 0, and then we also take an integer count is equal to 0, and then for int r is equal to 0, r is less than n, r plus plus, we have initiated this loop, and then we add or we include add nums r. And just like the previous template, we again run a while loop. While invalid, we shrink the window, and then we increment it with an L. Then the slight variation here is that we increase the count by r minus l plus 1, which is the size of the window at this moment. And now we're done. The one important trick that you should remember in this entire course of sliding windows is that whenever you are asked exactly k, in any question, if there's a mention of exactly k, you need to make sure that you know that at exactly k is basically at most k minus at most k minus 1. And that's it for today's video. We explored the different patterns and templates for all the sliding windows questions, and this comes in very handy when you're actually solving one. And in the next video we'll be covering the different questions that we can do with sliding windows and other topics as well. So stay tuned. Bye.